Hi friends, welcome back to my YouTube channel. So today we are going to discuss about flow control. So this is the first part that we are already discussed about data link layer. So there it have the MAC control and media access control and data link layer control. So in data link layer control, those have two control needs to be defined. The first one is flow control and second one is error control. So today we are going to discuss about flow control. So flow control we have already talked about that. The data communication required at least two devices working together, one to send and other device to receive. So even such a basic arrangement requires a great deal of coordination for intelligible exchange to occur. So this is the way the flow control is the most responsible for data link layer, that are flow control and error control. So in the flow control defines that how these coordination happens between the receiver and the sender. So this is defined by the flow controller. So flow control coordinates the amount of data that can be sent before receiving an acknowledgement and is one of the most important duties of DLL. DLL means data link layer. So flow control coordinates the amount of data and that can be sent before receiving an acknowledgement and is one of the most important duties of DLL. So in most protocol, flow controller is a set of procedures that tells the sender how much data it can transmit before it must wait for an acknowledgement from the receiver. So what it's saying is, so sender is sending one data to receiver. So sender needs to wait from the acknowledgement from the receiver node and how much data it is transmitting from the sender. So the data link layer, the flow controller controls the set of procedures that controls the how much data it can transmit before it must wait for an acknowledgement from the receiver. So receiver to sender there is a flow control occur because sender sending some data from sender to receiver, and these data size is determined by the flow controller. So this is a figure that you can draw in your answer sheet when you are when you are answering for the flow controller questions. So data link layer connections are there, and one sending node and receiving node, and sending node produces one data and it's pushing some frames from sender to receiver, and receiver receiving and then acknowledging back to sender that I can access or I can receive this data from sender, and there this flow control occurs that it controls the how much data it can transmit from sender to receiver before waiting for an acknowledgement from the receiver. So this is the introduction for the flow controller, and the flow of data must not be allowed to overwhelm the receiver. And why we are doing this flow controller is the receiver cannot be overwhelmed with the data that is flowing from sender to receiver, and any receiving device has a limited speed at which it can process incoming data and a limited amount of memory in which to store incoming data. So this is why we are using flow controller, because the receiver have a limited speed of processing the data, and also it has a limited amount of memory to store the incoming data. So if the data in receiver overwhelms the receiver, there must be a problem that can occur due to this overwhelming of data in the receiver. So to avoid this, we need to apply this flow controller in the receiver and sender. And the receiving device must be able to inform the sending device before those limits are reached, and to request that the transmitting device to send fewer frames or stop temporarily. So this is the basis of acknowledgement that receiver giving to sender. So receiver giving the sender one acknowledgement, that basically means that informing the sending device to limit the data that they are sending to receiver, or request the sender to transmit fewer frames or stop temporarily. So this is the acknowledgement that receiver giving that to sender. And incoming data must be checked and processed before they can be used. So that means they need to check before the incoming data and processed before they can be used. And the rate of processing is often slower than the rate of transmission, and this is also a problem. While sender is transmission speed can be a high compared to the processing speed of the receiver. So for this reason, the receiving device has a block memory called buffer reserved for storing incoming data until they are processed. So what they are doing is the receiver needs to be checked before they are using this data from the data sending from the sender. They need to check before they are using. So to do that, they have a block of memory called buffer to reserve for storing the incoming data until they are processed. So if buffer begins to fills up, the receiver must be able to tell the sender halt transmission until it is once again able to receive. And this time also the receiver needs to give one acknowledgement that from the buffer it is full, the data is fills up in the buffer. So the receiver must to acknowledge the sender that to halt the transmission until it is once again able to receive, or until it processes the incoming data that fills in the buffer. So this is the process. This is where we need the flow controller in data link layer. So flow controller refers to a set of procedures used to restrict the amount of data that a sender can send before waiting for an acknowledgement. So this is the definition for flow controller. So you can use all these words when you are writing exam related to flow controller. So the main part is coming. So error control is the error control. So we have already seen the data link layer have two functions. One is flow control and second one is error control. So this is an introduction for the data link layer functions, flow control and error control. So first we have seen the flow controller, and second we are going to see about some basic information regarding error control, and we are going to discuss this more in the next section also. Now, error control is both error detection and error correction, and it allows the receiver to inform the sender of any frame lost or damaged in transmission and coordinates the retransmission of those frames by the sender. So what happened here, the error control is error detection and error correction. So what happened if any frames lost or damaged in between the transmission, these error control or error detection or error correction devices coordinate the retransmission of those frames by the sender. And in DLL, error control refer to the error detection and retransmission. So once they detect the error in the frames, and then they need to retransmit it. So this will be done by the error control. And error control is simply implemented in DLL anytime an error is detected and exchange specified frames are retransmitted. So anytime if an error identified in the frames that is sent by the sender, they will retransmit the frames at the specific time. So this is the process called automatic repeat request. So that means Arcq. So we are dealing with Arcq in the upcoming sections. So the types of Arcq, automatic repeat requests, that are happening in data link layer. So error control is the data link layer. Error control is in data link layer is based on automatic repeat request, which is the retransmission of data. So basically error control is the retransmission of data. Whenever they detect an error in the frames, it will coordinate with the sender to resend the frames from the sender to receiver. So this is happening in error control. So next we are going to discuss more about the flow controller protocols. So DLL can be combined framing, flow controller, error control to achieve the delivery of data from one node to another. So data link layer combines a framing, flow controller and error control to achieve the delivery of data from one node to another, that means sender to receiver. And these protocols are implemented using common programming languages. And protocols are divided into two. One is noiseless, error-free channel, and this is not used in real life because it's just an abstract scenario that we are discussing. And noisy means error creating channels. So first we are going to discuss about the noiseless channel, that is error control, error-free, and the classification of these protocols are already we have discussed the noiseless channel and noisy channels. So in noiseless channel, simplest and stop and wait we are discussing now, and in noisy channel, stop and wait Arcq, go back and Arcq, selective repeat Arcq. So in noisy channels we are discussing in next section. So today we are going only discuss about the noisy channels, noiseless channel. So to an introduction for these protocols, so there is a difference between the protocols we discussed here and those used in real networks. All protocols are unidirectional in sense that the data frames travels from the one node called the sender to another node called receiver. So this is an abstract scenario, that's why I called it an abstract scenario. Always the data is unidirectional, that means one sender to receiver or receiver to sender, this is happening. So normally it is not, normally we in real life it is bidirectional. Sender can send data to receiver, receiver can send acknowledgement to sender also. So in here it is unidirectional, one-way communication, sender to receiver or receiver to sender at a time. And also special frames called acknowledgement frame, Arcq, and negative acknowledgement frame, NAC, can flow in the opposite direction of flow and error control purposes. Data flow in only one direction. So to ease our task, we are doing this in unidirectional, and in real life DLL are implemented as bidirectional. In this protocol, the flow and error control information such as Arcq and NAC is included in the data frames in a technique called piggybacking. So piggybacking is another technique that we are used in the normal real life. So Arcq and NAC is included in the data frames in the technique called piggybacking. So you remember this name piggybacking, we are discussing in this at last of this section. So first we are going to discuss about noiseless channel. So noiseless channel, assuming that we have an ideal channel in which no frames are lost, duplicated or corrupted. So this is the scenario that we are discussing, an ideal channel and there are no frames are lost or duplicated or corrupted. And there are two protocols for this type of channel. First one does not use flow control and second one that does. So first one we are discussing simplest and second one is chop and wait. So in simplest one we are discussing only, so it have no flow control, we are not using flow control in that, and second one we are using flow control. So these protocols neither has error control because we have assumed that the channel is a perfect noiseless channel. So we are removing the error control part because as we discussed it's a noiseless channel. And first one we are going to discuss is simplest protocol, and since it has no flow or error control we will call it as a simplest protocol. So this is why we are calling it as simplest protocol, since it has no flow control and error control. So this is a unidirectional protocol in which data frames are traveling only in one direction from sender to receiver, and we assume that receiver can immediately handle any frame it receives with a processing time that is enough to be negligible. So we assume that we already discussed that if receiver having lesser processing time compared to the sender transmission speed, so it will take time to process the data that sent from the sender. So here we are telling that the sender speed, transmission speed and the receiver processing speed are almost same. So that means the receiver can immediately handle any frame it receives with a processing time, and the DLL of receiver immediately removes the header from the frame and hands on which can also accept the packet immediately. So here also the DLL receiver immediately remove the header from the frame and hands which can also accept the packet immediately. So we have already seen that the frames are having header and tail including the data. So the receiver will immediately remove the header frames from the data that they have received and also accept the package immediately. And in other words, the receiver can never be overwhelmed with incoming frames. So this is the thing, the receiver never be overwhelmed with incoming frames. So this is a design for the protocol. So what we are going to do, so we can see we have the layers like physical layer and data link layer and network layer. So sender is sending data from network layer to data link layer. So what they are doing, so this figure shows the diagram for the seamless protocol. So there is no need for flow control in this scheme. So when you are writing, you need to remember that the flow controller, there is no flow controller in the seamless protocol. And data link layer at the sender side. So this is the sender side and this is the receiver side, and this is the sender side and this is the receiver side. And so sender side gets the data from its network layer and makes a frame out of the data and sends it. So what happened? The sender receives a data from the network layer, and then it is sent to data link layer, and data link layer at the receiver side. So data link layer at the receiver side receive the frame from the physical layer, and extract the data from the frame and delivers to the data it's to network layer. So what I mean, sender gets the data and send frames to data link layer, and then the receiver side, the data link layer receive the frame from the physical layer and deliver that to network layer. So this is happening in this protocol. And next is like the data link layer of sender and receiver provide transmission service for their network layer. So here we are considering that they are giving or transferring the data to or from network layer, and the data link layer uses the services provided by their physical layer, such as signaling, multiplexing and so on, for the physical transmission of bits. And so this is the figure 4. So we have discussed that physical layer is transmission of the data in form of signals. So they are using the multiplexing options to get the data to frames, and the frames of data is changed to signals, and then it is again changed to frames and sent from physical layer to data link layer, and then it is sent to network layer in the receiver side. So this is the diagram for the seamless protocol. So next one is, so you can write this diagram in the figure in the answer sheet. Okay, if you want, you can, this is the, if you are putting all the words in the answer sheet, it is not enough to get more marks. So you need to put the design figure in the answer sheet itself. And here you can see the repeat forever and the request from network layer, repeat forever, and algorithm for sender side. And in the sender side, event is notification from physical layer, and repeat forever algorithm for receiver side. And this we will discuss further from here. So we have seen that algorithm for sender side and an algorithm for receiver side. So what we are doing is, we need to elaborate once on the procedure that used in the data link layer. So what happened here, the sender side cannot send a frame until its network layer has a packet data to send. So once the network layer has the data to send to data link layer, it will receive the data from network layer to data link layer. So in the receiver side cannot deliver a data packet to which its network layer until the frame arrives. So this is the scenario, that once the network layer have the data to send to data link layer, it will receive that one. And the receiver side, once the data that it will occur from the physical layer, it will send the data to network layer. So the algorithm for the sender side is repeat forever. So like what it means, that once the data is there, the event is like, once the data is there, wait for the event. So if it is true, wait for the event. So or otherwise it can sleep forever. And if event is request to send, so network layer is requesting to send to the frame to receiver network layer. So what happening, if it is true, then it will get the data and make the frame and send the frame. This is happening in the data link layer and the physical layer, and it is sent to the receiver side physical layer. And the receiver side, what happened, the same thing, it is waiting for the update from the physical layer of the sender side, and if the event occurs, that event arrival notification in the receiver side occurs the event arrival notification, it will receive the frame, extract the data and deliver the data. So this is happening. So this is the algorithm for the sender side and receiver side. And for example, we are giving one flow diagram. So in flow diagram you can see it's an example of communication using the protocol. So it is very simple. The sender sends a sequence of frames without even thinking about the receiver, and to send 3 frames three events occur at the sender side and 3 events at the receiver side. Note that the data frames are shown by tilde boxes. A height of the box is defined the transmission time difference between the first bit and the last bit in the frame. So what here happened, the sender have 3 events, 3 requests and 3 arrivals in the receiver, and these blocks define, the lines in the 3 requests are defining the times gap between when they are sending and receiving. So it is almost same, and you can see the diagram shows almost same, that the sending time and receiving time is exactly same. And so this is the example for flow diagram of simplest protocol. And next we are going to discuss about the stop and wait. So before that I have put the notes regarding what I have explained for this protocol, so you can refer this also. I will just scroll down for a little bit of time. Okay, this is showing the design, and figure 1 is the design diagram of the figure, and figure 2 is the algorithm, sender side algorithm and receiver side algorithm is the 3. And then next is the figure 4. Figure 4 shows the flow diagram, example for the flow diagram. So the second one is stop and wait protocol. So in stop and wait protocol, if data frames arrive at the receiver side faster than they can be processed, the frame must be stored until their use. So in stop and wait we already discussed it having the flow controller. So what it means, we have a situation scenario like at the receiver side faster, the frames arrives at the receiver side faster than they can be processed. That means the receiver is overwhelmed with the data, and the frames must be stored under their use, because the frame needs to be inspected before their use. So they need to store it or in the buffer or something. And normally the receiver does not have enough storage space, especially if it is receiving data from many sources. So we are considering it as there is no enough storage space to store this data, and this may result in either of discarding of frames or denial of service. So this happening, this causes a discarding of frames or denial of service. To prevent the receiver from becoming overwhelmed with frames, we somehow need to tell the sender to slow down. So we need to tell the sender to slow down the process of sending frames to receiver. There must be a feedback from the receiver to sender, and also there must be a feedback from the receiver to sender. And the protocol we discussed now is the stop and wait protocol, because the sender sends one frame, stops until it receives confirmation from the receiver, okay to go ahead, and then sends the next frame. So that's why we got the name as stop and wait protocol. So once the sender sends one frame to receiver, the receiver will acknowledge or receive the frame and acknowledge it, and after, when it tells that it's okay to go ahead for next frame, then only the sender sends the frame, until then it will be in wait, or it will stop sending the frames from sender to receiver. So that's why it is stop and wait protocol. We still have unidirectional communication for data frames, but auxiliary Arcq frames, simple token of acknowledgement, travel from other direction. And we add flow controller to our previous protocol. And what happening in simplest protocol, we told you like there is no flow controller. So here we are adding flow controller. So that is the only difference between simplest protocol and stop and wait protocol. So the design is showing here. So what is the design describing is, the figure 1 is showing the exactly same as the, not exactly same, but the diagram if you see here, it is almost same. but in the sender side and receiver side there is some differences. I will explain what it is, and please draw this diagram in the answer sheet while you are answering your questions. So this will be helpful to get more marks. And figure 1 illustrate the mechanism, or comparing the figure with figure for the simplest protocol. We can see the traffic on the forward channel from the sender to receiver and the reverse channel. So there is a difference. The first difference is it has both traverse from sender to receiver and receiver to sender. So data is sending from sender to receiver, and acknowledgement frame is sent from receiver to sender. So this is the first difference, and at any time there is either one data frame on the forward channel or one Arcq frame from the reverse channel. So we therefore call it as half duplex link. So this is almost a half duplex link. And figure 2 is, so we have discussed this thing. So this is the only difference in there, okay. And data frame is sending from sender to receiver and receiver to sender, it is acknowledgement frame. And the figure 2 is showing the sender side algorithm and receiver side algorithm. So we are now discussing about the sender side algorithm. So in sender side algorithm, two events can occur: a request from the network layer or an arrival notification from the physical layer. So what happening here, comparing to the simplest protocol, there is only one event to occur, that request from the network layer. Here it is two events. So one is request from the network layer, second one is the acknowledgement frame, that is from the receiver to sender. So what is there? It is saying the repeat forever, allow the first frame to go. So if it is true, and wait for the event. If the event request is send and can send, then only it will get data from the network layer and make frame and send frame, and can send its flow and cannot send until the Arcq arrives from the receiver side. Okay, and wait for event, and if event arrival notification, then Arcq is arrived and it will receive the frame and can send is true. So this will follow, this will rotate like as it is the Arcq is received or request to send is there. So this is the protocol, algorithm for the stop and wait protocol. And here we are discussing, the name of the protocol is changed. I didn't change it. So this is for stop and wait protocol. Don't misunderstand by the name, simplest protocol. Okay, and so in here, so in other words, we can say that after a frame is sent, the algorithm must ignore another network layer request until that frame is acknowledged. And we know that two arrival events cannot happen one after another because channel is error free and does not duplicate the frames. So we are adding flow control in here, but we are not adding the error control. The request from one network layer, however, may happen one after another without an arrival of event in between. So we need to somehow to prevent immediate sending of data frame. Although there are several methods we can use, in a symbol can send variable can either be true or false. So here we are making can send variable as true or false, and when a frame is sent, the variable can set it to false to indicate that a new network request cannot be sent until can send is true. So what it is saying, can send is false once it is sending frame from sender to receiver, and it will indicate that the new network request cannot be sent until the can send is true. So when an Arcq is received, can send is set to true to allow sending the text from the next frame. Okay, so this is already we have discussed. So the next one is a receiver side algorithm. So receiver side algorithm means procedure at the receiver side. After the data frames arise, the receiver sends an Arcq frame to acknowledge the receipt and allow the sender to send next frame. And so this is happening in the receiver side algorithm. So while it is true, wait for an event. That means event arrival notification of the data from the physical layer or the network layer of the sender side, and it will receive the frame, extract the data, deliver the data, and send one frame, that is the acknowledgement frame. And the flow diagram for this diagram is shown as, the figure 4 is the sender side The sender sends one frame and waits for feedback from the receiver. Sender 1 send the frame and waits for the feedback for the receiver. And note that the sending frame in the protocol involves the sender in 4 events and the receiver in 2 events. So in sender side it is 4 frames and receiver side it's 2 frames. So what is happening? Sender side it is request one frame to send to receiver, and the sender wait for the acknowledgement from the receiver, that is acknowledge. And also another frame is sent from the request side, sender side, and it is acknowledged. So this is happening in the stop and wait protocol. So we are concluding these sections, okay, because we are already discussed 2 protocols. One is seamless protocol and second one is stop and wait protocol. So in the below this diagram I have added what I have discussed today for this stop and wait protocol design, and the figure explanation also. So you can refer that if you have any doubt, okay. And yeah, that's it. So we have discussed the 2 classification of noisy channels. So in next section we are going to discuss about noiseless channel. So it's a huge section, 3 protocols we need to discuss. So see you in the next video, and if you like this video please subscribe my channel, like, share and comment. If you have any doubt please post the same in the comment and I will provide you the correct responses after that. So thank you. See you in the next video.